Okay, 1.2, day 2, we're going to keep transforming absolute value functions. So we're going to start with example 0 to remind us what we did last class. So we're going to write the equations for the transformation of y equals the absolute value of x. Okay, so y equals the absolute value of x is translated 5 units up, 5 units right, and it's 1 unit up. Okay, it didn't tell me what to label my new function. I think I'm going to label it f of x. Okay, so 5 units right of absolute value. So absolute value of x minus 5 moves it right, up 1, plus 1. Okay, let's go to the next one. Y equals absolute value of x is reflected in the x-axis with a vertical stretch of 3. Okay, let's give it a name. Let's call it g of x. Okay, reflected in the x-axis means the y values are changing to negative, so let's put it negative. It's vertical stretch of 3, so the y's are multiplying by 3, and then we are doing this to the absolute value of x function. Okay, let's try C. Y equals the absolute value of x has a vertical stretch of 2, and it's translated 6 units right. Okay, let's call it h of x. You can have different names. Okay, vertical stretch of 2. So I'm timesing the absolute value by 2. And then what am I doing? I'm 6 units right. X minus 6. Vertical stretch of 2, 6 units right. Okay, now we're going to transform functions that are already kind of transformed and see the resultant of those functions. So example 1 says graph the function g that results from transforming the graph of f, then write the resulting function. Okay, so f of x equals the absolute value of x plus 2 minus 3 is already graphed here. This goes left 2, down 3. Left 2, down 3, and it's a nice V because it is absolute value. Okay, let's take this and move it 4 units right and 2 units up. Okay, I'm going to move the vertex because that's the easiest. I'm going to move it 4 units right. 1, 2, 3, 4, 2 units up right here. So that's my new vertex. Okay, it's still the same shape, so it's going to go something like this. Okay, now I'm going to write the equation for this just by looking at my resultant, but then I'm going to go back and do this algebraically. Okay, so this is my resultant. It's still absolute value. It looks like the vertex is right 2, down 1, which means this is going to be the absolute value of right 2, down 1. Okay, now if I didn't want to graph this, we need to figure out how did we get this answer. Okay, so let me go back to the original function. It was f of x equals absolute value of x plus 2 and then minus 3. Okay, now it went 4 units right. If it goes 4 units right, then this x plus 2 is going to go minus 4. Okay, now let's see what we got now. F of x equals, it's not f of x anymore actually. Let me not write f of x. So now what are we at? Let's do an arrow. So now this is the absolute value of x plus 2 minus 4 is x minus 2 minus 3. And now I want to go 2 units up. If I want to do 2 units up, what am I doing? Adding 2 to the end. Okay, so now what happened? Now I got the absolute value of x minus 2 minus 3 plus 2 gives me minus 1, and which is how I got to this answer without doing the graphs. Okay, let's look at the next one. Okay, so for this one it says reflect f of x equals absolute value of x plus 2 minus 3 in the x-axis. Okay, now normally when we reflect in the x-axis, we just make it go upside down. But in this case, it's already down here. So if I want to flip it over this line, I have to do it carefully. Now, because it's absolute value, I really just care about the vertex. So I'm going to take this point, and it's down here. I need to move it up to here. So how far is that? 1, 2, 3. 1, 2, 3. Okay, now it's flipped upside down, so it's going to go this way now. Okay, let's go ahead and try this. And if you look at it, it looks like a reflection on the x-axis. Okay, now if I just look at the resultant equation, my resultant graph, this is my g graph, it's negative because it's opening down. The vertex is left 2, up 3. left 2, up 3. And I could get the graph that way. Now, if I didn't want to get that graph that way, I wanted to figure it out algebraically. I start with the given function, which was the absolute value of x plus 2 minus 3. I want to reflect it in the x-axis, which I mean I want all the y values to multiply by a negative, which means I need to multiply the entire thing by a negative. Because I'm taking this graph and then flipping it. Okay, now when I distribute the negative, it cannot go inside absolute value, so we just keep it out there. And if I do the negative to the negative 3, it gives it a positive. And that's how we got that answer we just got right there. Okay, now let's try it with a stretch. We're going to graph it, and then we're going to do it algebraically. Okay, vertical stretch means that the y values are getting multiplied by 2, but the x values are not changing. So let's start with the vertex. So this is -2, -3. The x value is going to stay -2. The y value is going to multiply by 2. So instead of -2, -3, it's going to be -2, -6. Okay, now what else would be, let's think of a couple ways to do this. One would be if I go to 1, 0. The 1 stays the same. If I do 2 times 0, it's still 0, so it's going to stay right here. Same over here at -5, 0. The x stays the same. The y gets multiplied by 2, but that stays at 0. That's one way to graph it. Or I could say, oh, it's stretched by 2. So instead of going right 1, up 1, it's going to go right 1, up 2 on each side. Either way will get me a nice graph. Okay, let me go ahead and graph my new g of x. And I'm making it look like a v because it is absolute value. Okay, now if I just look at the graph, it was stretched by 2. Goes like that. Okay, now what is the new vertex? It goes left 2, down 6. So left 2, down 6. Okay, now the question is, how do we get that from the original equation without having to graph it every time? Okay, so if we start with the original function, which was this one, and when I stretch it by 2, I'm multiplying the y values by 2, so the whole thing gets times by 2. Okay, now we cannot distribute a 2 to an absolute value, so I just keep it in the front. But I can distribute the 2 to the number at the end, which is how I got the -6. Okay, now that we know we can graph it for sure, let's try to do this without the graph. Okay, example 2, they're going to give me a graph and I'm going to perform the following translation. If there's more than one translation, I'm going to be careful. Okay, so let's see. G is a translation 5 units down of f of x. Okay, so if I take my original function and I want to go 5 units down, normally the 5 goes at the end, so let's put a -5 at the end. This is kind of my scratch work. Okay, so my resulting function is g. So g of x, the absolute value of x minus 1. And since I minused 5 to the -3, now I'm at -8. And it kind of makes sense. This was right 1, down 3. If I go down 5 more, now I'm down 8. Okay, for B, H is a translation 8 units right of f of x equals the absolute value of x minus 1 minus 3. So 8 units right, where is that? That's in the parentheses. If I'm going right, it's normally x minus 8, but there's already a -1 there. So I'm going to -8 inside the absolute value sign. So now, oh no, what is this called? H of x. H of x is the absolute value of x, instead of -8, 1, now it's -9. And it's now down 3. Okay, and then let's think about this. Okay, this went right 1, down 3. If I go right 8 more units, now I'm going right 9, but I'm still going down 3. So they should kind of make sense. Okay, let's try a reflection. Okay, G is a reflection over the x-axis of the absolute value of x minus 1 minus 3. Okay, they're not just saying flip it, they're saying take this actual graph and flip the entire thing. So I'm going to multiply by a negative, but on the entire function. Okay, and then what is this called? This is called g of x. So now g of x equals, I cannot distribute a negative into absolute value, so I'm going to keep it in front. But I can distribute the minus to the -3, so now this is a +3. Okay, and again, we're going to think about this for a second. Okay, this one, right 1, down 3. But when I flip it over the axis, instead of going down 3, now it's way up here, which is why it's going up 3, because this thing got flipped up to this thing. Instead of down 3, we're up 3. Okay, let's do the same thing for the next one. H is a reflection over the x-axis of f of x, so I'm taking this entire function and reflecting it over the x-axis. So this whole thing is getting multiplied by a negative. What are we calling this thing? H of x? Okay, I'm going to keep the negative outside the parentheses because I are the absolute value because I can't distribute it, but I can distribute it to the 5, so now it's a minus 5. And remember, think about whether that makes sense. This was a graph, it was like left 4, up 5, and it opened up. If I flip it over the axis, now it's going to be way down here, and it's opening down. Okay, how about stretches? Okay, G is a vertical stretch by 4 of this thing. So I can't just put the 4 in the front. I'm stretching the entire thing. So let me take this original function. And all the y values are getting times by 4. So something like this. Okay, let me rewrite this. What is this called? G of x? Yeah, G. Okay, again, I can't distribute to absolute value. So I'm going to keep the 4 on the outside. I can distribute to the 3, so now this is going down 12. So instead of going down 3, now I'm going down 12 because I'm going 4 times as far. Okay, h is a vertical stretch by 2 of f of x. So this is going to be h of x. Okay, and what am I going to do? I'm going to times the entire thing by 2. Because I'm multiplying this graph. Okay, so this is negative 2. And then 2 times 5 is 10. Okay, now what happens if we have more than one transformation? So we're going to do a combination of transformations. Now when you're doing a combination of transformations on a function that is already transformed, you do need to do it in the order they indicate. Otherwise it actually changes your graph. Okay, so let's start with the first one. It says the graph of y equals the absolute value of x plus 3 plus 2. First thing is it's moved 6 units right. So let's look at this. So I had x plus 3, 6 units right, minus 6, plus 2. Okay, what does that give me? That gives me x minus 3 plus 2. Okay, then what do they want me to do? Okay, then they want me to reflect it in the x-axis. So now I'm going to flip it. I moved it, now I flip it. So now I'm going to times the entire thing by a negative. Okay, and now I've gotten to my resultant equation. It didn't tell me what to label it. I can call it y equals, I can call it f of x equals. Okay, and then that's my final equation. Okay, let's try another one like that. Okay, the graph of y equals the absolute value of x minus 1 minus 3. This thing's already transformed, which means it's going to be a little bit of a mess. So first they want me to stretch it by 5. So let's times it by 5. 5 times x minus 1 minus 3. What does that give me? That gives me 5 minus 15. Okay, now they want me to move it 7 units up. So I'm adding 7 on the end. Let's see what we get. We get y equals 5 times the absolute value of x minus 1. Negative 15 plus 7 is negative 8. Okay, so that's my resulting function. And be really careful because the order really does matter. If I had done this differently, if I had moved it 7 units up first, negative 3 plus 7, that would have made it 4. And then if I stretched it by 5, I would have ended up with some kind of 20 at the end. So it's actually going to change your graph a lot if you don't follow the sequence of the combinations correctly. Okay, go ahead and try the practice problems. When you're done, unpause the video and check your answers. Okay, go ahead and check 1 through 4. It told me my function was going to be function g, so that's why I labeled them all g of x. Okay, when you check, look at your numbers, look at your signs, look at the location of your absolute value bars. Okay, go ahead and pause the video. Unpause when you're ready to check the next ones. Okay, go ahead and check your answers for 5 through 10. again, look carefully at your negative signs, the numbers, the absolute value bar locations, and everything else.